This question is taken from November 2020, and this question is an application of the centripetal force. Let's understand. So, in this question, they say the rotor in amusement park, as you see, it is a cylinder which can rotate about its axis of rotation. Right now, it is moving counterclockwise, so it will have a angular velocity that can change. And we see a passenger which is stick from the inner side of the cylinder. All right, and there is a floor. So this is a floor that is right now with the attached with the passenger, but in this question they say the floor of the rotor has been lowered away from the person. So what will happen when the floor will be lowered at a certain angular velocity, because they say when the cylinder rotates sufficiently fast, the floor drops out. Okay, so I'm right now drawing the two free body diagram in order to explain it more well. The first one is a before lowering floor. Okay, when the person is standing on the floor, we know that how many forces are exerted on the person. The one force will be obviously the force exerted by the earth, that is the force of gravity mg, and the second one is this normal force, dear students. This is a normal force which is equivalent to, which is equal to the mg. You can also write it by letter n. Second, the third force is a small force, that is actually the normal force exerted from the inner cylinder. So let's say this is our normal force exerted from the inner cylinder that is pushing towards the center, but that is a small force. Now I'm coming to the point. They say when the cylinder rotates sufficiently fast, so the floor is lowered. What will happen when the floor will be lowered? Now the weight that is not changing, so this weight has to be countered by some other force. All right, because they say motionless, the passengers stay motionless. Why passengers stay motionless? Let me show you here. So when we will lower this, now there is a no normal force at all applied by the surface on the passenger. So now the frictional force, all right, dear students, the frictional force is the only force that will exert on the passenger, that will counter the weight. All right, so mg. So this frictional force must be at least equal to the weight in order to acquire this condition. All right, whereas now look at here, I am drawing a longer vector of this normal force. Why? Because this normal force is directly proportional to the angular velocity square. I will prove it later. So the first question is about the free body diagram for the person. So in this diagram, you have to draw the three vectors. The one is a normal, the frictional force. The other one is the weight. And remember, this is a normal force exerted by inner surface. So dear students, this is an arrow that is a horizontally towards left, towards the center of the cylinder. So we don't you think we should say this is a centripetal force, because it is providing necessary centripetal force, and it is not countered by any force towards right. So that's why according to Newton's second law, this is a unbalanced force, and we can also call it this is a net force or the resultant force. All right, and this normal force is equals to ma, and this acceleration is v square over r, and hence you know that this is the centripetal force equation. Okay, now we are not going to use this formula. Why? Because in this question is about the rotational motion, and this is a factor that is changing, omega, angular speed. All right, so what is the relation between the linear speed and angular speed? That is v is equals to r omega. So if I put the value over here, okay, so what it will become, the normal force will become equals to r omega square over r. So if you open this one, so what is the equation of the normal force that we get? And the normal force, don't forget, this is a centripetal force. So mr omega square. Now we got an equation in terms of omega, angular velocity. All right, w square. Now in this question, next question, they say derive the minimum angular velocity required. This is a minimum angular velocity at which, if the rotor will rotate, the person will stay motionless. This should be the minimum velocity, but how we can derive it? So dear students, you know that this is a centripetal force, and what is a condition of staying motionless? So that is this one, that the frictional force must be at least equal or greater than the force of gravity, right? So because we are setting equation, this is an equation, so we would say that at least the frictional force should be equal to the weight. All right, now this is a static friction, all right, because the person is staying at rest, and which is equals to mu s, and the normal force is equals to fg, and we can say mu, like, because this is represented by the letter mu, so mu normal force is equals to mg. All right, and if I put the value here, mr omega square is a normal force is equals to mg, and you have to cancel the mass with this mass, and this will be the angular velocity, g over mu r. So in this equation, this mu is a coefficient of static friction between person and cylinder. So this is a minimum angular speed. So angular speed means that how many rotations the cylinder is completing in per unit time. If it is completing, let's say in the next question, you see 28 revolutions per minute. So you can find angular velocity. Let's calculate it. So let's use this data. This is a coefficient of static friction, that is mu, and this is the radius of cylinder. So first of all, let's calculate the minimum angular velocity required, g over mu r. Okay, so its answer is 2.64 radian per second. That is a standard international unit, 2.64. But this is a minimum angular velocity threshold required. Okay, now we have to compare it with the actual angular velocity with which the rotor is rotating. Okay, so what is the actual value? That is 28 revolutions per minute. Okay, now dear students, in a one revolution we know there are 2 pi radians. In degrees it is 360, so it will be 28 times 2 pi radian divided by 60 seconds, and let's see. So its answer is 2.93 radian per second. Okay, so it means, of course, the actual value of angular speed is more than 2.64, the minimum required. It means that the passenger will stay motionless. Just a side note, just a concept, a basic fundamental concept. The omega is the number of rotations per unit time. Okay, so that is per second. So for example, it's a 28 revolutions divided by 60 seconds. So it means that the actual speed of the rotor is 0.46 revolutions per second. It means it is completing almost one half revolution in 1 second. Just in last few seconds, see, this is the official mark scheme released by the IB board, and everything is according to this, and you can still ask me any question about this.